Hello everyone. I am Revathi. I'm working as assistant professor in SNS College of Technology in Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic about SQL injection. We use applications daily, logging into bank accounts, checking results, ordering food, and making payments. But behind these apps, the database is constantly receiving user inputs. If these inputs are not handled safely, attackers can also trick the system. The main issue begins with how user inputs are used in SQL queries. In many applications, whatever the user types like username, ID, phone number is directly added to the SQL query without checking or sanitizing it. This creates a huge security risk. So, our core problem is how do we prevent attackers from injecting malicious SQL code into our database queries? If we don't handle input properly, attackers can steal data, modify it, or even delete entire tables. That's why SQL injection is still one of the top cybersecurity weakness. To understand the seriousness, let's empathize with the actually happens by looking at a real story. In 2017, an Indian financial portal suffered a massive breach. The attackers didn't use any advanced hacking tools. They simply took advantage of small text box that asked for account number. The system was taking whatever the user typed and directly putting into a SQL query. So the attacker entered a small piece of malicious SQL code. Immediately, the system returned every customer's data, names, phone numbers, balances, everything. More than 3 lakh users were affected. Imagine the damage. Customers received spam calls, there was fear, and trust in the company was completely lost. This is the real human side of poor database security. SQL injection is not just about coding errors. It affects real people, families, and their safety. So now let's define the concept clearly. SQL injection is a technique where attackers insert harmful SQL commands into input field or URLs. If the system doesn't validate the input, the attacker's command gets executed by the database. Let's take simple example. Suppose the application uses this query. Select star from users where ID is equal to user input. Now, instead of a number, the attacker enters or 1 is equal to 1. The query becomes select star from users where ID is equal to null or 1. And since 1 is equal to 1 is always true, the attacker gets across to all records. This small trick can break the entire system. That's why understanding SQL injection is also important. Now let's think about where attackers usually try SQL injections. There are very common places, login forms, search boxes, URL parameters, and feedback forms, registration forms. First one is login form. Instead of typing your real password, attackers type something like or 1 is equal to 1 and bypass the login completely. The second one is search boxes. A harmless looking search field can become a tool for extracting sensitive data. Then third one is URL parameters. For example, www.site.com where products ID is equal to 10, an attacker can modify it to www.site.com where products ID is equal to 10 or 1 is equal to 1. Fourth one is feedback forms or registration forms. Any field that accepts text can be targeted. So now we know where attackers strike. Next, let's see how we can protect our systems. In this prototype stage, we think about how to build solutions to stop SQL injection. There are some very effective and widely used techniques. First one is prepared statements. Then second one is parameterized queries. And third one is input validation. Fourth one is escaping special characters. And fifth one is using least privilege roles. First one is prepared statements. These separate SQL code from user input. So even if if the attacker enters malicious or input, it will be treated only as text, not as SQL code. Second one is parameterized queries. This force the system to handle user input strictly as parameters, fixed, safe values. Third one is input validation. We check whether the input is in the correct format. For example, if we expect a number, we reject alphabets. If we expect an email, we check the pattern. Fourth one is escaping special characters. We convert characters like comma and dash dash into safe formats so they can't break the query. Fifth one is using least privilege roles. Instead of giving full access to every part of the database, we restrict permissions. By combining these techniques, we create a strong shield around the database. SQL injection attacks have been happening for more than 20 years. Some of the biggest examples include 2008 Hotline Payment System breach and 2011 Sony Pictures hack, in 2019 Indian government portal exposure, 2023 AI-based SQL injection scanners. Attackers are constantly upgrading their methods. That's why every new feature, new form, and new database change should be tested for vulnerabilities. Continuous testing keeps the system safe and reliable. Let's wrap up everything. SQL injection happens when user input is not sanitized. Attackers inject SQL code and gain unauthorized access. Prepared statements, parameterized queries, validations, and escaping prevent most attacks. Real incidents show us that SQL injection has serious human impact. Continuous testing is the key to stay protected. Thank you.